Hello everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem of the day, and today's problem is number of ways to divide a long corridor, and it is a hard level problem. So I was very happy to see a hard level problem after a very long time, but after solving a problem, I wouldn't really say it is a proper hard level problem. I would say it is on the easier side of the hard range of difficulties. So anyways, let us just quickly discuss what the problem says. It says that we have been given a library corridor, and there are some seats and there are some plants. Now we have to divide this whole corridor. Since this is the corridor, we have to divide into some smaller corridors such that each corridor can have exactly 2 seats and any number of plants, right? So the number of plants can be anything, but the number of seats should be exactly 2. So we have to find the total number of ways in which this particular configuration can be achieved. So you see here they have put an artificial corridor here at this particular position. So there are 2 seats here and 2 seats here. Now we can also put it here. So there are 2 seats on the left and 2 seats on the right, and the last position is here. So 2 seats on the left and 2 seats on the right again. So again there are 3 number of possible combinations. In this particular configuration, since there are 2 seats in total only, so this is the only configuration possible. In the last test case, they have shown only 1 seat. Since we want at least 2 seats in one single corridor, the answer will be 0. Right. So again, I'm repeating this part again, that we need exactly 2 seats and any number of plants. This is the whole problem. So the problem itself is not very difficult. You just have to figure out how to implement this problem, right? Because I believe implementation would be the more difficult part rather than the understanding of the problem. So let me just draw seats. Let's say we have seats and we have some plants, right? Plants, and then some seats, and then some plants, then some seeds, plants, seeds, plants, right? That means I can these are 2 seats, the first 2 seats, so I can place a corridor here, or I can place a corridor here, or I can place a corridor here or here, right? So you see there were 4 choices. There were 4 choices for me to place a corridor after the first 2 seats. Now similarly, after the second 2 seats, I have one choice here, I have one choice here, or I have one choice here. Again I have 3 choices here. Now after these 2 seats, I have one choice here, I have one choice here, I have one choice here. But I need to understand, for the last 2 seats, do I really have a choice? The answer is no, because if I put a corridor here, if I put a virtual corridor here, then there will be only 2 plants remaining, right? That means for the last 2 seats, I don't really have a choice, right? Let us just repeat this part again. So what I was saying is, since after every 2 seats, I was having a choice where can I put a wall to divide the whole corridor into smaller corridors. But after the last 2 seats, if I try to put a corridor here, then there will be only 2 plants remaining, which is not possible for the last corridor, right? So that is why for the last 2 seats, I am not going to put any walls, and the original wall that was there will be there only. So the total number of ways will be these walls multiplied by these walls, right? So in this case, the answer will be 4 into 3, that is 12, right? So you see, the most important observations here are, as soon as I find my second seat, a pair of seats, after that I can try putting the corridors, and I can put them until I encounter a new seat, right? So this one has 4 positions and this one has 3 positions. This is the first observation. Now the other observation is, for the last 2 seats, I cannot put up a wall, because otherwise either plants will be remaining or the last corridor will have nothing at all, right? And at the end, once I have all these values, I can just multiply them to find the total number of ways, because they can exist independently of each other, right? So what you see here is, what I have done is, I have initialized a vector called points. So basically this will be storing what are the total number of ways I have, and I have initialized my modular value, and I have also initialized the corridor size with n, and I am going to calculate the total number of seats in total variable and my current index as index variable. So while index is less than n, I am going to execute this loop. As soon as I find a current index, at the current index I have a seat, I am going to increment my total value, and if total is even and total is a non-zero value, right? So in that particular case, normally I would increment my index, and then I want to count the number of ways. So count will be initialized with 1, and while corridor of index is not equals to another seat, right? So while index is less than n and corridor of index is not equals to another seat, I'm just going to increment my count and index as well. Now after this whole process, if index is less than n, I'm just going to push the current count into my points vector. So why is this particular condition index is less than n? You see, I talked about why for the last two seeds we are not going to consider the number of fields, right? So if index becomes equals to n, that means the current two seeds that we have encountered are going to be the last two seeds, right? That is why we are just going to ignore them. So only if index is less than n, I'm just going to increment my points vector, right? Or this add this particular value to the points vector. So if this was not true anyways, I'm just going to increment my index value, right? So at the end, if total is odd, that means the total number of seats are odd, and that means at least one seat will be remaining alone, and that was not acceptable, so I'm going to return 0. Or total is equals to 0, that means there was no seats at all, right? So I missed this particular case and made a wrong submission first, but you have to be sure that there should be exactly two seats, right? So if there are no seats at all, in that particular case, the number of weights will be 0 as well, right? So at the end, what you can do is initialize your answer with 1, and you're just going to traverse the points vector, and you're going to multiply your current value with answer and take the modular value, and after that we can return answer. So this would be the solution of this particular problem. Let me just quickly submit this and show you that this particular solution works. So you see, I got my first wrong answer, and that was because I did not include this particular condition that total can also be 0, right? So that was it for this particular video. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share your thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.